Welcome geometry students to the homework help video. Here's the video right here. Here's the assignment right here. Page 598, 4 through 12, 17 through 19. And hopefully this video will help you on the homework that you're struggling with. Let's take a look first of all at numbers 4, 5, and 6. The directions read as follows. You can follow along in your book if you would like to. AB is tangent to circle C at A. DB is tangent to circle C at D. Find the value of x. Now, for numbers 4, 5, and 6, they all have one thing in common, and please listen to me carefully. They have a tangent segment coming off of a circle and a tangent segment coming off of a circle, and they're coming from the same point. Now, what we learned in class when we studied 11.2 was this. Whenever two tangent segments are coming from the same exterior point, in this case B, those two segments will always be congruent. Always. So if the length of this line right here is 4, then the length of this tangent segment here is 4 also. So x equals 4. Let's take a look at number 5. Same thing. It seems pretty easy, but it's very important you understand this. I have a tangent segment right here and a tangent segment right here. Remember, tangent means the line or the segment intersects the circle in exactly one place. Notice they come from the same exterior point B. That means those two tangent segments will be congruent. So if the length of this one here is 2, then that means the length of this segment here is also 2. So x equals 2. Number 6, it's almost the same thing. Notice we have a tangent segment here and a tangent segment here, and they're both coming from the same exterior point B. Anytime two segments are tangent to the same circle and they come from the same exterior point, then those two segments will be congruent. So if the length of this segment here is 10, then the length of this whole segment here is also 10. So instead of saying x equals 10, we're going to say that 2x equals 10, because this segment here is 2x and this segment right here has to be equal to this segment here. So 2x equals 10. Divide both sides by 2. Your 2's cancel. X equals 5. Okay? Pretty simple algebra there. Alright, now numbers 7, 8, and 9, they tell us that line AB is tangent to circle C. Find the value of r. Now please listen, students. We had a theorem that said this. If a line is tangent to a circle, and notice how line AB is tangent to the circle and is tangent right here at point A, we had a theorem that said the radius, if there's a radius drawn to the point of tangency, and again the point of tangency is where the line is tangent to the circle and this line is tangent to the circle at A. If we have a radius drawn to A, then there will be a right angle right there. The two lines are perpendicular. So that means line CA and line AB are perpendicular. Now if they're perpendicular, that means I have a right triangle right here. So very quickly I'm going to cut this triangle out. So here it is. It goes down to here, and then it goes to here, and then here. So there's my triangle. Now I'm going to slide this out of the way. Now remember, this is a right angle here. See how this length here is r, so I'll put an r right here. This length right here is 5, so I will put a 5 right here, and this length right here is 4. I will put a 4 here. And now we're going to solve for the value of r. Well, Pythagorean's theorem. One of my legs is r, my other leg is 4, and my hypotenuse is 5. So very quickly, I have r squared plus 16 equals 25. Now bring the 16 over and make it negative, and when you do, you're left with 9. Now take the square root of both sides, and you're left with 3. The square root of r squared is r, and the square root of 9 is 3. So r equals 3. What you need to remember here, students, is when a line is tangent to a circle, it will be perpendicular to the radius that is drawn to the point of tangency. So here is my tangent line for number 8. Here is my radius. Notice how my radius is being drawn right to the point of tangency. So that means this line right here, CA, and this line right here, AB, are going to be perpendicular. Those two lines will always be perpendicular as long as you have a tangent line and a radius being drawn to the point of tangency. So, with that in mind, I'm going to cut out the triangle. So there's the triangle. Let's pull the picture out of the way. Now remember, I have a right angle here. Notice this length here is r, so I'll put an r here. This length here is 15, so I'll put a 15 here. And this length right here is 17, so I will put a 17 here. And now once again, it's just like the last problem, Pythagorean's theorem. So I have one leg is r, the other leg is 15, and my hypotenuse is 17. All right. Well, if we have 15 squared, we're going to get 225. And if we have 17 squared, we'll get 289. So we have r squared plus 225 equals 289. Now bring the 225 over and make it a negative 225, and you're left with 64. And now take the square root of both sides. The square root of r squared is r, and the square root of 64 is 8. So there we go. We did it. The answer is 8. The length of r is 8. I'm going to say it for the third or fourth time. When you have a line that is tangent to a circle and a radius drawn to the point of tangency, those two lines will be perpendicular. Okay, number 9. Notice I do have a tangent line here, and the tangent line is AB. And notice I do have a radius right here drawn to the point of tangency. So lines CA and AB will be perpendicular. They will be. Okay, so let's cut out our triangle like we always try to do here. And now let's label the pieces. We have a right angle here. This would be 25. This would be r, and this would be 20. So it's really redundant, but it's the exact same problem 3 times in a row. So what we have is one leg is r squared, the other leg is 20, so 20 squared, and the hypotenuse is 25 squared. Okay? Well, if you square 20, you'll get 400, 20 times 20. And if you square 25, you will get 625. All right, now bring the 400 over and make it a negative 400, and you're left with r squared equals 225. And if you take the square root of both sides, the square root of r squared is r, and the square root of 225 is going to be 15. And so the answer is 15. So again, what they're drilling into your heads here is when a line is tangent to a circle and a radius is drawn to the point of tangency, those two lines will be perpendicular. Now for 10, 11, and 12, these are going to be like the first 3 that we did, 4, 5, and 6. For numbers 10, 11, and 12, the directions say A and B and A and D are tangent. Find the value of x. So once again, now we're reviewing again. Notice that I have a tangent segment here, and notice I have a tangent segment here. So here's what I have. I have 2 segments that are tangent to the same circle, and they come from the same exterior point. Whenever that happens, this segment right here will be congruent to this segment here. So if this segment here is 7, then x equals 7, because this segment here also has to equal 7. Okay, number 11. Now same thing. Notice I have a tangent segment here and a tangent segment here. That means I have two tangent segments, or two segments that are tangent to the same circle, and notice they both come from the same exterior point. When that happens, that means this segment here is always going to be congruent to this segment here. So I can take my x plus 4 and set it equal to the other segment, which is 19. And now bring your 4 over and make it negative, and you will get 15. Okay, moving on to number 12. Same thing. Notice how I have a segment here, tangent to circle C, and a segment here, tangent to circle C. So I have two segments that are tangent to the same circle, and they come from the same exterior point. So what does that mean? That means this segment right here that I'm highlighting in blue is going to be congruent to this segment right here. So if those two segments are congruent, then I can take 5x minus 8 and set it equal to 2x plus 7. Now let's solve this quickly. Bring the 2x over and make it a negative 2x. Bring the negative 8 over and make it a positive 8. And we're left with 3x. Of course, this is gone. And this is gone. So I'm left with 3x equals 15. And now divide both sides by 3, and x equals 5. Okay? So pretty simple. There we go. Moving on. Numbers 17, 18, and 19. Now, what they tell us in the directions is that AB is tangent to circle C. And they want us to find the length of R. Now, these are going to be a little harder, so please pay attention and please watch, okay? First of all, they tell us in the directions this line right here is tangent. Let me get a different color here. This line right here is tangent to the circle. And then notice I have a radius drawn to the point of tangency, which is B. Anytime that happens, these two lines right here will be perpendicular. Okay, so I have a right triangle. So let's very quickly cut away our right triangle and see if we can solve for R. Let's pull this away. And now let's very quickly label our triangle. This will be a right angle. This will be R. This length here will be 4. And here's where it gets tricky. Please look at the diagram, students. The length from here to here, this point to here, is R. And then from here to here is 2. So this whole length right here would be R plus 2. You add those two together, and the whole length is R plus 2. Okay, so here we go, students. Let's go ahead and solve for R. One of my legs would be R. My other leg would be 4. And then my hypotenuse, now watch how I do this. My hypotenuse is R plus 2, so I square the entire binomial. Now, be careful here. R squared plus 16, that's pretty easy, but R plus 2 squared does not mean R squared plus 4. You do not square the R and square the 2. That is incorrect. What you do is you write this parentheses twice. So you really have R plus 2 times R plus 2. And we should know how to do that. You take this R right here and you multiply it through. So R times R is R squared. R times 2 is 2R. Now you take your 2, your positive 2, and you multiply it through. So 2 times R is 2R, and 2 times 2 is 4. So what you're left with, if you combine like terms, is R squared plus 4R plus 4. Now I want to show you right now, if you were to, you see this R squared and you're like, oh, what do I do? Well, really it doesn't matter. If you bring this R squared over here, it becomes negative R squared, and they cancel out. And you say, well, Mr. Earhart, what if I brought this r squared over? Same thing. If you brought this r squared over, it'd be a negative r squared, and they still cancel out. So no matter what, your r squareds are going to totally cancel out. So they're gone, okay? So this r squared here is gone, and this r squared right here is gone. So here's what you're left with. You're left with 16 equals 4r plus 4. Well, we're solving for r, so we're going to bring this 4 over, and we're going to make it a negative 4, so it's gone. And now we're left with 12 equals 4r. And then we divide one side by 4, we divide the other side by 4, and we're left with 3 equals r. And there we go. We got it right. 3 equals r. Let's try number 18. Okay, number 18, same type of problem. Notice I have a tangent line here, AB, and I have a radius drawn to the point of tangency right here. So those two lines will be perpendicular. So with that in mind, let's go ahead and cut out the triangle here. And I think it's going to be a pretty sick looking triangle, but that's okay. We'll go ahead and color it in a little bit, so make this a little straighter side. Alright, so there's our triangle. Okay, well, looking at this diagram down here, it looks like this length here is 8. My right angle is here. This is 12, and this is r. And actually, I misspoke. This length right here is not 8. I'm wrong. If you look at the diagram here, from here to here is 8, and then from here to here is r. So I do have 8 plus r. Okay, so with that in mind, let's solve this problem. One of my legs would be 12, my other leg would be r, and my hypotenuse is 8 plus r squared. Okay, well, if you square the 12, you get 144. If you square the r squared, you'll get r squared. And now, over here on your own, you can pause the video, students, and go ahead and write 8 plus r times 8 plus r, and go ahead and try that on your own. Okay, then turn the video back on if you want to. But if you take this 8 and multiply it through the other parentheses, then take this r and multiply it through, you should get this right here. You should get 64 plus 16r plus r squared. Now remember, your r squareds will cancel. If you were to bring this r squared over, it'd be negative, or vice versa. It doesn't matter. So this r squared right here is going to be totally gone, and this r squared right here will be totally gone. So what you're left with now is 144 equals 64 plus 16r. Now we'll bring the 64 over, and when we bring it over, we'll make it a negative 64, and we're left with 80. So 80 equals 16r. If you divide both sides by 16, 5 equals r. Okay, and that's the answer. So one more and we're finally finished. Okay, I hope you're getting these okay. All right, let's take a look at number 19 and we're done. Notice that once again, I have a tangent line right here, and I have a radius drawn to the point of tangency. So those two lines are perpendicular. So let's go ahead and cut this triangle out here real quick. And I might just make that triangle a little bigger, just so we have something a little bigger to work with. Alright, and what we have here is we have a right angle here, and this side up here is r, and this side here is 21. And then notice here in the diagram, from here to here is r, and then from here to here is 9. So this whole length right here for the hypotenuse is r plus 9. Okay, so let's go ahead and solve for r, and we're finished with the homework assignment. Okay, here we go. One of my legs would be r, my other leg would be 21, and then of course I have r plus 9 quantity squared. Well, if you square 21, you're going to get 441. And if you square, again, feel free to write this off to the side, r plus 9, and work it out. Then look up here and see if you got it right. But what you should get is r squared plus 18r plus 81. Okay? Now remember, your r squareds are going to cancel. So if you were to bring this r squared over and make it negative, it would cancel out with this r squared over here. So let's go ahead and write now what we're left with. We're left with 441 on this side equals 18r plus 81. Well, we're trying to solve for r, so we're going to bring the 81 over and make it a negative 81. And we're going to be left with 360. All right? 360. Now if we take 360 and we divide that by 18, we're going to come up with 20. And that is the correct answer. 20 equals R. So let's review the three things that we learned in this lesson. We learned number one, let's go back a little bit. We learned that when two lines are segment to the same circle and they come from the same exterior point, those two segments will be congruent. We learned that when you have a tangent line like this and a radius drawn to the point of tangency, those two lines will be perpendicular. And by the way, we also learned the opposite. I don't think it was covered in the homework, but we also learned that when you have a right angle here, then we know this line is tangent, and this line here, if you have a radius drawn to a line that's perpendicular, this line right here is tangent to the circle. Okay, so I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.